Welcome. Today we're going to learn about how to find certain features of parabolas or quadratic formulas. Now, the last lesson you went over talked about a quadratic in what's called vertex or transformational form. Vertex or transformational form, where f of x equals, and sorry that's a big X, I kind of messed up there, but f of x equals some stretch times, in parentheses, x minus h, where h is a horizontal shift, in parentheses squared, plus k, where k is a vertical shift, up or down. Well, if you're given the equation in this form, what can we pull right from the equation? Well, we can pull what we call the axis of symmetry. Now recall that a parabola, and I'm just going to draw a little example over here, is a U shape that comes down like this and goes up like that. Or it could be upside down. In other words, it could be facing downwards. But either way, it has what's called an axis of symmetry, a line that goes right through what we call the vertex. The vertex is the very highest or very lowest point, depending on whether it's opened up or down. And the axis of symmetry is this vertical line that goes right through the vertex. And in vertex or transformational form, it's just this h value. Make sure you remember that this is a minus sign. So if it's x minus, and let's look at an example here. If it looks like this, f of x equals negative 1/2, parentheses x minus 5 plus 6, the vertex's x value, the x value for the vertex, is positive 5. And the axis of symmetry, if they ask, and they'll ask for the equation for the axis of symmetry, which is a vertical line with an x value of 5. So the axis of symmetry would be x equals 5 for this particular equation, or this particular parabola. So we write the axis of symmetry as an equation, vertical line, x equals whatever that h value is, if it's written in this transformational form. The next thing it might ask for is the coordinate of the vertex. Well, we know the h value is the point of the vertex, the x value. Well, this is the vertical shift, this k value. That's actually the y value for the vertex. So again, if I was to go back to this equation right here and ask, what is the vertex? Well, the vertex lies along the axis of symmetry, or it has an x value of 5, and it has a y value of 6. So this a value that sits out in front, right here, this a value has no effect on the vertex or the axis of symmetry. Okay. It also might ask you to find what is the minimum value or maximum value of the function. Well, the minimum or maximum value is the y value at the vertex, which is just the k value. So on this function here, again, if they were to ask you what is the, and they'd have to ask you what is the maximum value, because this negative means it's open down, but they'd ask what's the maximum value. The maximum value would be 6. So it's the y value at the vertex. The last thing they might ask for is they might ask for what is the y-intercept. Well, the y-intercept is not quite so easily found in this type of an equation. The only way you can find the y-intercept is to actually plug in a 0 in for x and solve. In other words, find the point 0, f of 0. Remember, this is function notation. It's just saying find f of 0. So back here on this equation here, the only way I could find the y-intercept is I would actually plug a 0 in here. You know what? I noticed I forgot a little squared right here. There should be a squared there for it to be a quadratic. Without the squared there, it wasn't a quadratic. But now it is. But anyway, to find that y-intercept, plug a 0 here. 0 minus 5 would be negative 5. Negative 5 squared would be 25. Then I would take negative 1/2 of 25, which would be a negative 25 halves. And then I would add 6, which is the same as 12 halves. I just got a common denominator. And then negative 25 plus 12. The y-intercept for this equation would be 0 and negative 13 halves. Negative 13 halves would be the y y-intercept. Okay, now I kind of jumped around there. Let's do it again with this next equation. So let's do it with this one. Let's first find the axis of symmetry. Then let's find the vertex. Then let's find the minimum or maximum value. And then let's find the y-intercept. Well, it's very easy. The axis of symmetry is just x equals, now be careful here, it's actually going to be a -9. That's the axis of symmetry. The vertex is going to be the point -9, which is on the line of axis of symmetry, and this -4. There is the vertex. If it asked for the minimum value, and they would ask for a minimum value, because this is positive, it's opened upwards, it would be -4. And if they ask for the y-intercept, again, all you can really do is plug in a 0. 0, oh, I forgot the squared again on this one. I've probably done that all the way down. Squared. So I plug a 0 in here. 0 plus 9 is 9. 9 squared is 81. 81 times 7 is 567 minus the 4. So the y-intercept would be 563. So axis of symmetry, vertex, minimum value, and y-intercept. Now, they might not give it to you in vertex or transformational form. They might give it to you in general form. General form is f of x equals ax squared plus bx plus c. There's no parentheses. And you can't find the vertex or the axis of symmetry that easily when it's given to you in this form. But it's still possible. And I'm going to show you the formula that you use. The axis of symmetry is found by taking the value in front of the the value in front of the x, this b value, putting it over twice the a value, and then change the sign on it. They say that's a minus b over 2a. And then to find the coordinate of the vertex, so this would be the axis of symmetry, so we'd actually have the x value for the coordinate. The only way to find the y value is to plug whatever that value is back into the function. That's what this is. I'm plugging back in the negative b over 2a into the function to find the y value for the vertex. Now again, that y value of the vertex is also going to be your max or minimum value. The y-intercept actually is very easy in general form. The y-intercept is just the c value right here. It's just the c, because the y-intercept is when you plug in a 0. 0 and 0, those cancel out, and you're left with just c. c is your y-intercept, 0c. So let's do an example of that. So here's an equation in general form. The first thing I'm going to do is find the axis of symmetry. And I find that by doing a negative b over 2a. Well, my b value is the number that's in front of the x, so that's going to be 4 divided by 2 times the value in front of the x squared, which is a 1. A lot of times it's just a 1 x squared, so it'd be a 2 times a 1, and then I change the sign, or I get 4 over 2 is 2, and it's negative 2. So my axis of symmetry would be x equals -2. Now, to find the vertex, what I would do is the vertex has that x value of -2 on the line of symmetry, but now I just got to plug that back into the original equation. So -2 squared would be 4, plus 4 times -2 would be -8, minus 9, and I would get 4 minus 8 is -4, -4 minus 9 more is -13. There would be the vertex. Now, if it asks for the maximum value, the minimum value, and it would be a minimum because this is x squared is positive. It's positive, it's opened upwards. The minimum value would be this -13. So you'd say the minimum is -13. Now, if they asked you for the y-intercept, the y-intercept is very easy on this one. It's just the c value. It's just -9. 0, -9. It's the y-intercept. Now, a lot of times they will give you a quadratic that's missing the middle term. Don't let that confuse you. I'm still going to find the axis of symmetry by doing a negative b over 2a. But guess what b is? If there's no middle term, b is 0. So it's 0 over 2 times this, but I don't care, some number. What's 0 divided by some number? It's 0. The axis of symmetry is x equals 0. So then to find the vertex, again, it has a x value of 0, plug that in there. The vertex actually has a y value of negative 5, which actually is also the y-intercept. So the y-intercept, see, x value of 0, y-intercept. So that one made it easy. Again, this would have a minimum value of negative 5 because it's opened upward. I'm going to stop here. I'm going to do a few from the iExcel program and upload a video on that as well that you could watch me walk through some of the ones from iExcel. But if you have questions, do bring them to class and I will help you.